Today we have the great honor to have Gene Ekster here from the Alternative Data Group. Gene was here last year and gave a terrific talk about machine learning and alternative data. Why not have Gene come back and talk about some other alternative data, right? So thank you again.
Great. Thank you, Peter. This one is about personally identifiable information in these data sets, and there's very little regulation that talks about how personally identifiable information and other nagging questions about compliance have to be dealt with. But hedge funds want to be proactive about this. Is this compliant? Can we do this? Is this legal? Up until recently, there was no good answer to this. Now, more recently, there's been an organization that was formed called the IDSO, Investment Data Standards Organization. It does exactly what we talked about, which is publishes best practices and standards that addresses some of these issues specific to alternative data. So a lot of times in alternative data you have a string like this. Order 5565, Pizza Hut, meat lovers, pizza, pizza. Okay? Like that. And from that you have to get that it's Pizza Hut consistently. So word2vec doesn't work here. Why doesn't it work here? Because word2vec, you can think about it as just the average of the words around the word. What we want is that if somebody writes Pizza Hut and somebody else writes PZZAHUT, those have similar values. So how do we get that? That has to do with embedding it at the character level and using character classes like in regular expression to embed that, to train that character embedding system. One of the more interesting trends is that data sets are getting combined with each other, and they're being combined with survey data. Now, this is pretty new. Up until recently, data sets have been monetized and sold independently. One really great example of this is survey data combined with raw transaction data. And the way that works is that you can create a couple of questions in a survey such that you can then join it onto the transaction data. This is data from 7 hospitals. It is showing you the different colors are the different types of procedures they do. Not all hospitals do all procedures. Okay, some hospitals specialize. So this is the original data. What you can see is it's not just that the data starts in the middle and goes to the right side of the screen. No. It starts and it stops and it starts again and there's islands and it's just a mess. Okay? That's what the real data looks like. But if we wanted to just analyze the data in a way that if it were perfect, we would just have all of the cells in the matrix filled out, right? That's what we would want. So actually ADG developed a system. This is something that we've worked on quite a bit that uses, we call it GAPS. It's a generative adversarial panel stabilization. So it actually, in the end, the data looks like this. So it basically gets filled in, and you can see the complicated dynamics of each hospital are preserved. How do we know this stuff is accurate? Just out of sample. We delete more data here. We basically do gaps on it, and we see how accurate it is, and it's always within 1 to 7%. If you can imagine, the system is not too dissimilar to predictive type on your phone. First case study has to do with subscription services for Netflix and Charter and those kinds of companies. The data set is credit card transactions, anonymized credit card transactions. There are a couple of questions. One is, can we identify subscribers in the credit card transaction? The second is, what is Netflix and other OTTs doing to MSO ARPU? The approach to solving this problem, this was a very almost classic textbook Bayesian approach. It was basically to build a prior distribution about how people typically pay their bills, how many days from the last time they paid their bill, and what that distribution looks like, and then basically use that information in combination with the person's payment stream to forecast that probability that we just discussed. But it gets a little bit more complicated than that, because all of a sudden we see a payment to a competitor. Would you say it's a higher probability now that they're not a subscriber of the first one? Yeah, probably. They probably switched. So, there's a bit of like a additional naive Bayes kind of calculation going on that just informs us more or less, are we more or less confident that they're a subscriber? What's interesting about this system is every single day we know whether they're a subscriber or not, even if we don't see any transactions from them. So what was the overall analysis of this whole investigation? What you can see is actually the months after Netflix, it goes up a little bit. The ARPU actually goes up a little bit, not down, not statistically significant, but it goes up a little bit. And basically what it is that people get addicted to content and they just consume more and more content. as they buy Netflix. So they don't go to the internet only until they churn. When they churn and they subscribe to a new MSO, so maybe they move or maybe they go to like a new provider, that's when they usually make the decision to switch down to internet only. So those MSOs that are the best at maintaining their customers are also the best at maintaining a high ARPU. That was the conclusion. If you think about incentives of the hedge fund industry, do hedge funds care about the activities of an individual? No. Do they care about the activities of masses, of the trends? Yes. How do we debias a data set? There is a new trend in this industry to actually not do modeling. If we had all of the data, right, if we had the entire population, for some of these measurements, we wouldn't actually need a model at all. So what people have realized is if we use metrics that come out of the totality, or they're related to the entirety of the population, and we have a sample, we can actually weigh the data by changing the rows instead of changing the columns to make it more representative of some external benchmark. One of the approaches, okay, create an error metric and minimize that error metric by putting weights on the different rows of the data. First, cluster the rows into some kind of group. So if these are individuals, these would be like maybe grouped by socioeconomics or demographics. Then weigh them. It allows you to then use that weighted data, minimizing the distance to that error metric. Then you also minimized the bias for other dimensions of the data. Now everybody knows that Uber and Lyft are killing the taxi business. But how is Uber and Lyft impacting the car rental industry, like Hertz and Avis? Now, what I really love about this case is that the outcome of it is a very, very simple graph. And it is incredibly deceiving in its simplicity about how much work and sweat and intelligence and just brute force it took to get here. It's interesting, people that don't know the industry as well, they think there's a correlation between a simple chart and a simple analysis. And then other people know that sometimes a simple chart is like an iceberg where you have the majority of the work underneath, and this is one of these cases. The data came from email receipt data where it was completely unstructured, so all these questions like we've talked about before, structuring data and trying to figure out the outliers and just all of this stuff had to be done before you even start the analysis. And how do you identify when somebody's traveling? And how do you look at only the people that have enough data, but looking at people that have enough data adds its own bias? And so there's just an incredible number of complexity that is involved in this one simple chart. And so what does that simple chart show? It shows simply that people that use Uber, once they start using Uber, their rental car usage when they travel reduced almost twofold. And their Uber usage when they travel is threefold that of a regular person, of a regular Uber user. So obvious conclusion, they are using Uber when they travel instead of the rental cars. So this was a very timely analysis.